All right, so when we start looking at sinusoidal waves, um, there are certain characteristics, certain physical traits of the wave that we can identify from the graph itself and also from the function. Okay, and one of the more important characteristics is amplitude. Okay, and the way that I can explain it is this: when you talk about, and I'm not trying to relate waves to lines, but when you talk about a linear equation or a linear function, right? This number slope indicates how steep the line is, right? So we had a specific place to look in slope intercept form to determine how steep the line is. We had a specific place that we could look to determine where the graph intercepts the y-axis, right? So amplitude is one of these physical characteristics that we want to know about a sine wave. All right, and so I've got the definition here. You can pause and write this down. I'm going to refer to this a couple times. The amplitude of a wave is half of the distance between its max and its min. So we're only looking this way, right? How high up and down does the wave go? A typical, and what we're looking at here is a very basic sine wave, okay? So this is just sine x, which we can see the period starts at 0, it ends at 2 pi. The critical points of the sine wave, we start at an intercept, we go to the max, then an intercept, and then the min, and then the intercept. So here is one period of a basic sine wave. Okay. The amplitude is half of the distance between the maximum point and the minimum point. So the maximum point up here is 1. The minimum point down here is -1. So when you think about that distance, the distance between two numbers, and whether those numbers are vertical or on a vertical number line or on a horizontal number line, we subtract them, right? So we take the number that's typically the larger number and we subtract the smaller number and we get 2, and we're taking half of that, right? So we're doing this calculation. So for this sine wave, the amplitude is 1, okay? Now for calculating amplitude, I'm gonna clear this ink more than a few times here, but all of this should kind of end up in your notes in one place. So the amplitude of this graph is 1, right? We can say that, I'm going to say lowercase a for amplitude, all right, is the max minus the min divided by 2. That's how we take half. So if you want to look at the amplitude as a formula, when you have the graph in front of you, if you can identify the y coordinate of the maximum and the y coordinate of the minimum, subtract those two and take half. That's your amplitude. What side note, why are we interested in amplitude? The larger the amplitude, the more energy a wave has, right? So there's a physics connection here. When you talk about the energy of a wave, sometimes they talk about frequencies, like they talk about intensity, right? There's reasons that we can't stare directly into the sun because of the intensity of those ultraviolet rays and whatnot, and their ability to carry that energy. So amplitude is connected to that. I'm not sure we'll ever get to that point, but we'll let your physics teachers in the future take a crack at it. So that's one reason why we like talking about amplitude. This is a formulaic approach to amplitude. One thing you want to keep in mind, okay, crucially important here and kind of nitpicky, but still important, is that amplitude, okay, is always positive. That's something we're going to mention again. So, and the placement of the amplitude in a sine wave is always the coefficient, right? Think of it like this. When we were talking about transformations, okay, and again, I'm going to relate it to something else. When we talked about a parabola, okay, we said that if you put a number in front where you're multiplying a constant times that, right, that was a vertical stretch. So if we put a constant value here and we made that 4, that took the parabola from being just normal to being really thin, okay? The same is true for amplitude. We give it a definition here. It has a proper name. So amplitude is the vertical stretching of the graph. Imagine you're taking the two parts. Let's see if I can mimic this here with the actual drawing. Okay, imagine you're taking the minimum and the maximum and stretching. That's going to increase the amplitude. So we see that constant in front of the function itself. So in a sine function, we're going to see, or a cosine function, which we will talk about. In a sine function, that number shows up in front, okay, in here. So you can identify the amplitude of a sine wave by looking at the coefficient of sine. Understand that this number will be negative from time to time, but the amplitude is always positive. Okay, so it's the distance between the max and the min, right? Cut in half. It is formulaically looking like this. From the graph, we can identify that, and from the function, we can look in front of the function. One other thing I will mention, okay, like I said, a lot going on here with amplitude. One other thing that I will mention with amplitude is this. Every wave has a line of equilibrium, at least that's what I call it. I'm not exactly sure what the proper name for it is. So for this sine wave, the x-axis here is this line of equilibrium, okay? Meaning, it sort of straddles the midway point. It's like a midline for the wave. Maybe we should just call it the midline. I call it the line of equilibrium. You guys want to call it the midline? We'll call it the midline, okay? The midline of a wave, okay, whether that's the proper term or not, it's going to be our term. The midline of the wave is that horizontal line that cuts through the middle, okay, where basically this distance matches this distance. Okay, so if you want to consider the amplitude, if you can find that midline, you can identify that, the amplitude is simply the distance from the midline to the max, right? We said that the amplitude of this wave is 1 because the distance between the max and min is 2 and half of 2 is 1. Well, if you can identify the midline as the halfway point, then both the min and the max are 1 unit away from that. Okay, so multiple ways to identify amplitude from the graph, from the function. Okay, we're going to look at it tabularly later on, if that's even a word. All right, I should stop.